Hi, welcome to my channel. In the previous video, we discussed about MNST dataset and training a binary classifier, and measuring the accuracy using cross validation, confused matrix, precision recall F1 score, and precision recall trade-off. Okay, so these are the different topics we discussed in the previous videos. Just to go through those things to understand the ROC curve. So here MNS dataset contains 70,000 images of handwritten digits divided into two parts. One is training and testing purpose. So for the training, 60,000 images are classified, divided into training purpose, and 10,000 images are assigned for the testing purpose. So on this data set, you are going to apply a binary classifier. Okay, now on this binary classifier model, we are going to predict the performance of the model accuracy based on the accuracy using the cross validation. So there are different performance metrics are there to find out the accuracy of the model. Here, confused matrix is one of the best model. So here, precision recall F1 score and precision recall trade-off are the different types of performance metrics are applied on our model. And also we can see the one more type of performance metric, that is called as a ROC curve. So the ROC curve is also called as the receiver operating characteristics curve. ROC curve is another common tool used with binary classifier. Okay, so this is the one of the best performance measure to find out the accuracy of the model. So it is very similar to precision recall curve. So but instead of plotting the precision versus recall curve, we are going to use the ROC curve that plots the true values, the true positive ratio, the true positive rate, that is also called as a recall against the false positive rate. That is simply it is called as a ROC curve. That the ROC curve is going to plot between the TPR, true positive ratio, and false positive ratio. Simply this curve is called as a ROC curve. That is called as a receiver operating characteristics curve. Okay now. So now the FR is the rate of negative instances, false positive ratio, okay, that are incorrectly classified as a positive. So that is equal to 1 minus true negative ratio, which is the ratio of negative instances that are correctly classified as a negative. So TNR is also called as a specificity. TNR is also called as a true negative ratio, is also called as a specificity. So that is a TNR equal to true negative by true negative plus a false positive. So hence the ROC curve plus the sensitivity versus 1 minus specificity. Okay, so simply that is called as the ROC curve. To plot the ROC curve, so you first use the ROC curve function to compute the TPR ratio, true positive ratio, and false positive ratio for various threshold values. Okay, from the sklearn to matrix, we are going to import the ROC curve. So here we are getting the different values of the FR, TPR, and the threshold values equal to ROC underscore curve, y underscore train underscore 5, y underscore scores. Then we can plot the FR against the true positive ratio using the matplotlib. So the code here the code is define plot underscore ROC underscore curve. Further, we are providing the false positive ratio, true positive ratio, label equal to, we are providing the none value, and plot dot plot, FPR, TPR, line width equal to 2, label equal to label, and plot dot plot, the x variables are between the x-axis contains 0 to 1 and y-axis contains 0 to 1, and the dotted lines are to the lines between the two things. Okay, plot dot ROC and plot underscore ROC underscore curve between the FPR and the TPR, the plot dot source. Okay, it shows the true positive ratio on the x-axis, false positive ratio on the x-axis, and true positive ratio on the y-axis. That shows the ROC curve. Okay. Once again, there is a trade-off. Okay, if the higher the recall value, higher the recall value, the more false positive ratio, more false positives are the classified the produce. Okay, the dotted line represents the ROC curve of a purely randomly classified. So a good classifier stays far away from that line as possible. Okay. So one way to compare the classifier is to measure the area under the curve. Simply is also called as a AUC, area under the curve. So okay, ROC curve, this is also called as a ROC under AUC, area under the curve. So a perfect classifier will have a ROC and under area under curve is equal to 1. Whereas a purely randomly classifier will have a ROC-AUC is equivalent to 0.5. So scikit-learn provides a function to compute the ROC-AUC curve function. So from the sklearn dot matrix import ROC underscore AUC score. So ROC underscore AUC underscore y underscore train underscore 5 comma y underscore score. So it gives the 0.96. 0.96 is very close to 1. Okay, since the ROC curve is similar to the precision recall curve, you may wonder how to decide which one is the use. So as a rule of thumb, you should prefer the PR curve, precision recall curve, whenever the positive class is rare, or when you care more about the false positives than the false negatives. Okay, so otherwise you can use the ROC curve. So for example, looking at the previous ROC curve and ROC-AUC scores, you may think that the classifier is really a good model. Okay, but this is the mostly because of there is a few positives compared to the negatives. That means less number of positive elements are there, more number of non-5 elements are there. Okay, so in contrast, precision recall curve makes it very clear that the classifier has room for the improvement. That is, the curve could be closer to the top left corner. Okay, now let's now try a random forest classifier and compare its ROC curve and ROC-AUC scores to those of the stochastic gradient classifier. Okay, first we need to get a scores of the each instance in the training data set. Okay, but due to the way it works, the random forest classifier class does not have a decision function method. Instead, it has a predicted probabilities method. So scikit-learn classifier generally have one or other or both. So the predictor of probability function method returns an array of containing a row for instance and a column for the class, each containing the probability that given a instance belong to the class. So that is a 70% of chance that the image represents a phi class. From the sklearn ensemble model, now import sklearn.ensemble, import a random forest classifier. That means the random forest classifier present in the ensemble class, okay, ensemble model. So forest underscore classifier equal to random forest classifier. So random state equal to 42, y underscore probabilities s underscore forest equal to cross underscore val underscore predict forest underscore classifier, that is a model name, and x underscore train, y underscore train underscore 5, cv equal to 3, the method equal to predict of probabilities. So the ROC curve function expects the labels and the scores, but instead of scores, you can give the class probabilities. So let us use the positive class probabilities as the score. Y underscore score of forest equal to y underscore probabilities of forest of all the rows and single one column. Okay. So FR underscore forest to TPR underscore forest to threshold underscore forest equal to ROC curve of y underscore 10 underscore 5 y underscore scores underscore forest. So now we are ready to plot the ROC curve of the based on the random forest. So here it is useful to plot the first ROC curve as well as the see the how they compare the in this figure. Okay now. So plot FR comma TPR B blue color and label equal to stochastic gradient classifier the dotted lines. Okay, plot underscore ROC underscore curve in FR underscore forest TPR underscore forest, that is a random forest. Okay, the plot dot legend equal to location equal lower right and the plot dot show. Okay, here the random forest classifier ROC curves looks much better than the stochastic gradient classifier. It comes much closer to the top left corner. So here this is the dotted lens is the stochastic gradient classifier. Stochastic gradient classifier, whereas this one is the random forest classifier. Curve. Okay. As a result, ROC scores is also significantly better. So ROC underscore accuracy underscore score of y underscore 10 underscore 5 comma y underscore scores of forest equal to 0.99 compared to stochastic gradient ROC-AUC curve. Okay, the results of random forest and the ROC curve area under curve is 0.99. Okay, that is a way more compared to SGD random forest having the highest AUC curve value. So try measuring the precision recall scores. You should find that 99% of the precision, 86.6 recall. So you know that from the above slide models how to train the binary classifier. Okay, choose the appropriate metrics for your task. Evaluate your classifiers using the cross validation. Select the precision recall trade-off that fits your needs and use the ROC curves and ROC-AUC scores to compare the various models. So this is the way we are going to find out the performance metrics for the given model. So thank you for watching our video. Thank you.